My dear students, so far we have seen the topic vector algebra and we have completed the topic. Now in this video, in the CBSE syllabus, I am going to start the new topic, chapter number 11, three-dimensional geometry. It may be the continuation of vector algebra. The concept of vector algebra is to be carried out in this chapter also, in three-dimensional geometry. The three-dimensional geometry mainly dealt with the equation of straight lines and planes. And we will see one by one. First, introduction. The direction cosines and direction ratios of a line given in a three-dimensional space. See, OX, OY, OZ are the coordinates axis in three-dimensional space. OX, OY, OZ are the coordinate axis. And P, X, Y, Z be any point on the plane. Space I mean. X, O, Y, Y is a plane. P, X, Y, Z is any point on the space. OP is a line, a required line. The X, Y, Z are the direction ratios of the line OP. It is given by the vector R. OX, OY, OZ are the OX, OY and OZ are the coordinate axis in three-dimensional coordinate space. And P any point P, X, Y, Z, A, B, any point in the space, three-dimensional space. OP is a given line. OP is the given line passing through the origin. Passing through the origin. Passing through the origin. And R, that line OP is defined by a vector R. OP vector is defined by the vector R, that is given as XI vector plus YJ vector plus ZK vector, where I, J, K are the unit vectors acting along the coordinate axis. I cap, J cap and K cap are the unit vectors acting along OX, OY, OZ respectively. These are the things we have seen in the vector algebra. And also the line OP makes an angle alpha, beta and gamma with the coordinate axis OX, OY, OZ respectively. Alpha, beta and gamma are the angles made by the line OP with the coordinate axis OX, OY and OZ respectively. Suppose the line PO in the opposite direction. If you consider the line in the reverse direction, if you consider the same line, if you consider this line in the reverse direction, if we consider the line in the reverse direction, consider the line in the reverse direction, then phi minus alpha, phi minus beta and phi minus gamma are the reverse angle or the reverse angles made by the line PO with the coordinate axis. Phi minus alpha, phi minus beta and phi minus gamma are the reverse angles made by the line PO with the coordinate axis. These are the things. And cos alpha, cos beta, cos gamma are the direction cosines of the line OP. Cos alpha, cos beta and cos gamma are the direction cosines. Direction cosines of the line OP. Cos alpha, cos beta, these are the things you have seen already in our vector algebra topic. Cos alpha, cos beta, cos gamma are the direction cosines of the line OP. Here we are considering the vector, not vector OP, it's a line OP. Okay, and our vector is xi plus yj plus zk. So, modulus of our vector is the distance between O and P, that is equal to root of x square plus y square plus z square. So cos alpha, you know, x by r, mod r, x, this is distance x, this is distance y, and this is distance y. Ox, x is the x coordinate along the x axis, y is the y coordinate of the point along the y axis, and z is the z coordinate of the point along the y axis. So cos alpha, cos beta, cos gamma are the direction cosines of the line OP, and x, y, z x, y, z are the direction ratios of the line OP. The direction ratios of the line, and cos alpha, cos beta and cos gamma are direction cosines of the line OP. Now, relation between direction ratios and direction cosines. Now I am going to see the relation between direction ratios and direction cosines. Relation between the direction ratios and direction cosines. Relation between direction ratios and direction cosines of a line. That's our next concept. You know, cos alpha equal to x coordinate along the y-axis x by OP is mod of r. It is denoted as x by r. Similarly, cos beta y by r and cos gamma z by r. This is the angles direction cosine. Cos alpha, therefore x by r, y by r and z by r are the direction cosines or the DCs of the line, given line. Okay, and x, y, z are the direction ratios. You can consider this direction cosines by, we will consider DC's direction cosines by L, M, N, and direction ratios, general idea, general notation, direction ratios by A, B, C. So x, y, z are determined by A, B, C, and x by r, y by r, z by r are determined by L, M. So what is sum of the squares of direction cosines? Cos square alpha plus cos square beta plus cos square gamma is equal to L square plus M square plus N square. Because cos alpha is L, cos beta is M. So this is nothing but cos alpha is what? x by r. So this is x square by r square plus y square by r square plus z square by r square equal to l square plus m square plus n square. So from this you can consider the common LCM. L square plus m square plus n square equal to, by taking common LCM as r square, you will get common denominator r square is what is that, x square plus y square plus z square. If you take LCM, common LCM by r square, x square plus y square plus s square by r square, x square plus y square plus z square is again this what, r, that is r square. It is again r square by r square, that is equal to 1. So L square plus m square plus n square is equal to 1 you have. That is sum of the squares of the direction cosine is 1. Okay, and this x by r you denote by L. Okay, and these direction ratios you can consider by direction ratio A. What is the relation between and x by r is L? You will see. Okay. Now I am considering the direction ratios by A, B, C. Therefore, x by r I can identify A by r. A by r equal to L, B by r equal to M, and C by r equal to N. From this, A equal to LR, B equal to MR, C equal to NR. Where A is x, x, y, z, I mean. Direction ratios are A, B, C. What is L? Okay, R is root of r square is r is root of x square plus y square plus z square. This can be replaced by root of a square plus b square plus c square using plus or minus symbol, because r square is a square plus b square plus c square. So r is plus or minus root of a square plus b square plus c square. So you consider what is, from this we can consider A by L equal to R, B by R, L by A. What is it? R, okay, A by R equal to L, B by R equal to M, and C by R equal to N. Is it not? Okay? Yes. From this, L is equal to A by plus or minus A by R is root of A square plus B square plus C square. Similarly, M equal to plus or minus B by root of A square plus B square plus C square. Similarly, N equal to plus or minus C by the root of A square plus B square plus C square. Like that, you have to consider the direction cosines L, A by root of A square plus B square plus C square, and B by root of that. Okay, like that we have to find out the relation between direction cosines and direction ratios. That's all about the introduction about that direction cosines and direction ratios. Now using these ideas I am going to solve some problems. Okay. Consider the problem. If a line, given line in the space makes angle 90 degree, 135 degree and 45 degree with the coordinate axis, find its direction cosines. If a line makes an angle 90 degree, 135 degree and 45 degree with the coordinate axis, okay. Problem 1. If a line makes angles 90 degree, 135 degree and 45 degree with the coordinate axis, find its direction cosines. Find its direction cosines. That is the problem. Okay. What is meant by direction cosines? Direction cosines are cos value, cosine value of the angles. Suppose 90, 135, 45 degree are the angles made by the line with the coordinate axis yx, y, yz respectively. Alpha is 90, beta is 135 and gamma is 45. Like that is given. So direction cosines are cos 90, cos 135 and cos 45 degree. This is your direction cosine. Cos 90 is 0. Cos 135 degree equal to cos 90 plus 45. 90 plus 45 second quadrant cos negative 90 make it as sin 45, that is equal to minus 1 by root 2. So cos 135 is minus 1 by root 2 and cos 45 you know 1 by root 2. Therefore, the direction cosines are direction cosines are 0, minus 1 by root 2 and 1 by root 2. That is the answer for this problem. If an angle makes 90, 135 and 45 degree with the coordinate axis, then the direction cosines are 0, 1 minus 1 by root 2, 1 by root 2. That's all about the problem. Okay? Next problem. If the line makes equal angle with the coordinate axis, find its direction cosines. Second problem is, if the line, given line makes equal angles with the coordinate axis, equal angles with the coordinate axis, then find its direction cosines. Equal angle means all angles are equal, that is alpha equal to beta equal to gamma. All the three angles are equal because angle of made by the line with the x-axis is alpha, y-axis is also alpha and z-axis is alpha because the line makes an equal angle with the coordinate axis. Therefore, the DCs are you have to find out equal, since equal angles you have to if that line makes an angle, equal angle, same angle may be alpha. So the direction cosines are cos square alpha. Some of the squares of direction cosines you know, cos square alpha, cos square beta, cos square gamma equal to 1. Okay. The angles made by the direction line with the coordinate is equal, alpha, okay. All the three angles are equal. Therefore, cos square alpha, yes, but these three are equal. That is 3 cos square alpha equal to 1, cos square alpha equal to 1 by 3. So cos alpha equal to plus or minus 1 by root 3. This is cos alpha. So since all the angles are equal, cos alpha is plus or minus 1 by root 3 means the other direction cosines are also 1 by plus or minus 1 by root 3 because all the three are equal. Therefore, the direction cosines are, the line are, if therefore direction cosines of the line makes an equal angle with the coordinate axis is plus or minus 1 by root 3, plus or minus 1 by root 3, and plus or minus 1 by root 3. Because all the three angles are equal, these are the direction cosines. Okay, one more problem. Find the direction cosines if the drs are given. In this third problem, drs of a line are given. This is the direction cosines of this problem. If the drs of the line, if the direction ratios of a line are minus 18, 12 and minus 4. These are the direction ratios. Minus 18, plus 12, minus 4. These are the drs given. Find the direction cosine. If the drs are given, find DCs. That is our question. You know ABC are given. Drs given means ABC are given. A, B, C are given. A is minus 18, B 12, C minus 4. Find DCs. DCs you know. DCs are plus or minus A by root of A square plus B square plus C square. This is our result we have derived. Plus or minus B by root of A square plus B square plus C square, and plus or minus C by root of A square plus B square plus C square. This is our DCs. If drs are given, DCs, by finding these values we can find the DCs, direction cosines. What is A square plus B square plus C square? A square is 18 square, B square is 12 square, C square plus 4 square, 12 square plus 4 square. This is 324, 12 square is 144, 16. This is 484. So root of A square plus B square is root of 484, that is equal to 22. Root of 484 is 22. Therefore, the required DCs are plus or minus or plus minus here. 18 by 22. Or you just, for this problem, you just find out the sign only. What is given sign you can start. That is 12 by 22. Positive or negative according to the sign given in the dr. 12 by 22 minus 4 by 22. So this is by simplifying 9 by 11, 6 by 11 minus 2 by 11. So these are the direction cosines of the given line if the dr minus 18, 12, minus 4 are given. That's all about the problem. Okay, I will stop here and I will continue with the next video. Thank you.